All right, this is on half-life. So our next example involves exponential decay, and it is used to determine the age of fossils and artifacts. This method is based on considering the percentage of carbon-14 remaining in the fossil or artifact. Carbon-14 decays exponentially with half-life of approximately 5,715 years. The half-life of a substance is the time required for half of the given sample to disintegrate. Thus, after 5,715 years, a given amount of carbon-14 will have decayed to half the original amount. Carbon dating is useful for artifacts or fossils up to 80,000 years old. Older objects do not have enough carbon-14 left to determine age accurately. So let's go ahead and get to an example. So we're going to use the fact that 5,715 years, a given amount of carbon-14 will have decayed to half its original amount. Find the exponential model, the exponential function for carbon-14. So we're going to start off by using our exponential function model. And we're going to have our A naught be our initial amount. Our A be our end amount. Our T, or time, is 5,715 years. We're going to go ahead and substitute that into our formula. So our initial amount is some A naught. So after 5,715 years, is going in for T, we're going to have half the original amount left. And what we're going to do is we're going to solve this equation for K. So we're going to change that left side to 1/2 the original amount, and then the right side, I'm going to change that 5,715 times K. Now we're going to go ahead and divide both sides by A naught, the initial amount of substance. What will happen is the A naughts are going to cancel out. So the left side equals 1/2, the right side, exponential term of e raised to the 5,715k. Again, we're trying to find k. And k is that percentage of decrease as a decimal per 1 year. Now we're going to take the natural log of both sides. We take the natural log of both sides because e, base e, and the natural log are inverses of each other. So these two cancel out. So we're left with 5,715k on the right, and then the natural log of 1/2 on the left. Now we're going to divide both sides by 5,715. So then we're left with k equaling the natural log of 1/2, and I'm going to go ahead and put a parenthesis here, divided by 5,715. Now we would enter that into our calculator. K is approximately negative 0.000121. Now we can write our exponential model. So A equals A naught E raised to the, we're going to go ahead and substitute our K in, t. So this is our half-life exponential function or model. If we move the decimal 2 places to the right, what that's telling us is every 1 year, the product that you're watching will decrease by that percentage per 1 year. All right, in part B, in 1947, earthenware jars containing what are known as Dead Sea Scrolls were found by an Arab herdsman. Analysis indicated that scroll wrapping contains 76% of the original amount. Estimate the age of the Dead Sea Scrolls. So we're going to go ahead and use our formula from the previous slide. And now we're going to go ahead and substitute 76% in for your end amount. So this would be your initial amount, and then the left side is your end amount. So I'm going to change that to a decimal, 0.76 of the initial amount, and you have your initial amount. And now what we're going to do is we're going to solve for t. So to solve for t, we're going to divide both sides by a naught, the initial amount. Go ahead and cancel that initial amount. So we're left on the left is 0.76, on the right is our exponential term. And now we want to undo that e. So we're going to take the natural log of both sides. The e and the ln are inverses of each other, so they're going to cancel out. And now we can go ahead and undo this decimal value. So we're going to divide both sides. And now this left side is going to be going into our calculator. So go ahead and pause if you need to check to see that your answer is going to come out correctly. So time equals the natural log, I'm going to go ahead and put up parentheses here, all over our decimal value. And what you're going to get for time is approximately 2,268 years. So in 1947, that was when it started. So the Dead Sea Scrolls are approximately 2,268 years old, plus the number of years between 1947 and the current year.